Alright, looking today at indirect measurement. So indirect measurement allows you to use properties of similar polygons to find distances or lengths that are difficult to measure directly. And essentially what you're doing is looking at a couple different shapes and saying, well, because I know this information, I can now use something similar to find unknown information here. And you do this by setting up a proportion and solving. There are a couple of ways to, excuse me. There are a couple ways of setting up the proportion. As long as you're consistent in how you set it up, they both will work. Okay. So in this case here, you can see what they did is they said, well, let's look at the proportion and say, let's do Tyrone's shadow, which would be this distance here, 1.5, and let's set that over the light pole shadow, which is 4.5 there, and then we'll make it equal to Tyrone's height, 6, and the light post height, h. Okay. And in doing that, everything is staying the same. They're going with the little one, but the bottom side of each one of these, shadow to shadow, over height to height. And that's okay. You could also do just simply Tyrone's shadow over Tyrone's height, and set that equal to the flagpole's shadow over the flagpole's height. That would work as well. It really doesn't make a big difference, and I'll show you that here in a second. When you multiply this out, what do you have? You have h times 1.5, 1.5h, and 4.5 times 6, which is 27. So you end up at 1.5h equals 27. If I do this way, I end up with 1.5x, or h, equals 6 times 4.5, which is also 27. I just want you to see that, to recognize that as long as you're consistent in how you set up your proportions, it's going to be okay. So there's not really one perfect way of doing it. By solving this here, then I divide both sides by 1.5 to find that the x is equal to 18. So if I know this information here, I can solve for an unknown variable to find out what that's going to be. This is what's called indirect measurement, and we use proportions and cross products to solve that. Okay? Let's look at a couple samples here before we move on into your homework. So it says here that a monument, a statue casts a shadow of 30 feet. At the same time, a person who is 5 feet long casts a shadow that's 6 feet long. How tall is the statue? So let's look. I'll set up with the person here. The person is 5 feet tall and 6 foot shadow. Okay, so I'm going to go with this one over that one, and I'm going to make it proportional to the statue, the height, over its shadow, 30. Now, the first thing we want to do is we could recognize that, okay, I can use cross products, and we can get this figured out. So we have 6 times h is 6h equals 5 times 30, or 150. Okay, I can divide both sides by 6, and then find out that the height, in this case here, would be 150 divided by 6, which is going to be 25. Okay, that works. That's an easy way to solve it. Sometimes, though, what you can also do is recognize that I can say, well, I want to go from 5 to h, and using multiplication or division, how do I get there? Well, do I see a way to go from 6 to 30? Sure I do. From 6 to 30, I multiply by 5. So if I multiply this top one by 5, what is 5 times 5? Oh, it's 25. Well, what do you notice? That matches that. So sometimes by setting the proportion, you can see a relationship between the two and not even have to worry about doing the cross products. Okay, doesn't always work that way, but sometimes the numbers play nice. Okay, let's look at the next one. We have a height and looks like another shadow. So we're going to do 1.2 over the shadow 0.8. And here we have a height we don't know and a shadow of 72. Okay. Now, to go from 0.8 to 72, well, that actually is interesting because I know that 9 times 8 is 72. So if I had to guess, 0.8 times about 90 equals 72. So to go from there to there, I'm multiplying by 90. So if I multiply 1.2 by 90, I end up with 108. So without doing any cross products officially, I have 108 as an answer. But let's check it out with the cross product method. So I'm going to do 72 times 1.2. Oops, and 72 times 1.2, and we have 86.4 equals 0.8h. Now divide both sides by 0.8. Divide by 0.8. And we have 108 equals h. So, does it work? Sure it works. Both ways work just fine. Okay? So we can play with that to figure out unknown variables there. Let's take a look at this last one as an example, because you do have some that are going to kind of crisscross on you on your answers. So, all right. So you have two triangles are similar. Find the distance across the river. So we have from the middle point to the right angle 1, and right angle out 0.9. And over here, middle point to the right angle is what we call a D, and the right angle out there is 1.8. Again, you can notice a little similarity there real quick, but let's not worry about it. We're going to go 1.8 equals 0.9D. Divide both sides by 0.9, so that we have 1.8 divided by 0.9 equals 2. So our distance here is going to be 2, which kind of makes sense because if you look here, we're multiplying by about 2 to get 9 times 2 is 18, so 0.9 times 2 is 1.8, and 1 times 2 is 2, and you're good to go. So basically, set up the proportion, figure out what the missing measurement is, and that's it. So you have something to do today. Good luck. We'll see you for solutions in just a minute. All right, let's find out. The first one, how tall is Becky? Well, we have Becky's height over her shadow equals this thing, the mailbox's height, over its shadow, 4. We'll do some cross products. We'll have 4h equals 21. We're going to divide both sides by 4. So that h equals 21 divided by 4 is 5.25. So, not a very pretty answer, but it does work. Number 2, a couple extra pieces of information here. First, we have the person. So we have the person at 6.5, so we can write that as a decimal if you choose to, 6.5, and their shadow is 9. Is equal to the height, which we don't know, and the distance. Now be careful about the distance because this one, they're being a little tricky on you. The distance here is the whole thing. We can see it goes all the way out. So that's going to be 40.5. So be careful that you combine those there because that's the whole distance of that triangle. A little tricky part that they threw at you. Okay, so now I'm going to multiply 40.5 times 6.5, and I have 263.25 equals 9h. Divide that by 9, so I have 29.25 is the height of the flagpole. Okay, so that becomes my solution there. Again, I'm not sure why all the practice ones were nice numbers and now they give you crazy numbers, but sometimes that's the way math books work, isn't it? Okay, next one. How deep is the water? 50 feet from the shore. Okay, so we have this first part here, 8 feet from the shore. 8 feet from the shore, it's 1 foot deep, right? So 50 feet from the shore, we don't know how deep that's going to be. Okay, 50 and the h. So we're going to cross multiply, and we have 8h equals 50. We'll divide both sides by 8. So 50 divided by 8 is, our height is 6.25. All right, and the next one, let's see what we have here. How high is the ramp when it is 2 feet from the building? 2 feet. So we have the 22 feet. So we have, when it's 20 feet, we have 20 feet, we know that it's 2.5. So we have this and that. And what we want to know is what about if it's 2 feet away from it? So instead of being 20 feet long, this is actually going to be 18. So be careful there. And we need to know that height right there. Again, really weird numbers. Once again, I'm not sure why it's being mean like that. I think it's being mean. And so that becomes your setup. So we have 45 equals 20h. Divide that by 20. So we have the height is going to be 2.25. Again, it's not going to have a 2 here because we're doing this triangle there. So it's a little smaller than the large triangle. Weird, weird numbers. Man, this is weird. Number 5. How far is the water ride from the roller coaster? Around the nearest 10th. Okay, so we have the water ride. roller coaster, we want to know this distance right there. All right, well, because these are isosceles triangle, this distance matches this distance matches this distance. So looking at this one here, I have a 21 over 10, and this one I have a 45 over what I don't know. So multiplying that, we have 450 equals 21D. So 450 divided by 21 is 21.42 is about the distance from here to here. Okay, which makes sense. We can see that's a little less than half, and that's a little less than half there. Perfect. And number 6, our last one, how far is the entrance from the gymnasium to the band room here? Okay, again, we have some similar triangles here. We have the distance from that one to the 3, so 25 over, we can do 25 over 32 and set that equal to 30 over D. Cross multiply, we have 25D equals 30 times 32, which is 960. Divide both sides by 25, and D is equal to 38.4. Alright, those are my answers. All crazy answers, especially after the warm-up stuff, which was nice simple numbers, but that's just fine. Sometimes it's how it works. Okay, hope that helps you out. Hope you did okay. A couple more to go and we're almost done with the unit. Bye-bye.